Welcome to my channel, and here we'll be solving this question 3a. As we have here that the sketch in figure 3 shows point M and N 50 apart. Point P moves such that its distance from M and N is always in the ratio of 2 to 1. So that is what we are given the question, and this diagram that is being referred to. So distance between these 2 points, point M and point N, is 50 as we have here, and we have point P here. So we are asked to plot the locus of point P, as we have here that plot the locus of point P for 1 revolution. The question carries 10 marks as we have here. So let's see how this can be done. So what we need to do first is to so we are going to draw a line. So on this line, I'm going to take a measurement of 50 millimeters. A measurement of 50 millimeters. So this is 50 millimeters from here to here. So which means this is point M as we have in the question, and this is point N as we have in the question. So then the next thing that we are going to do, as we are told in the question that the ratio at which point P is from point M is 2, and that of point P from N is 1. So what we are going to do is to divide this distance MN into 3 equal parts based on what we are given as the ratio 2:1. So we add 2 plus 1, that will give us 3. So we are going to divide this distance into 3 equal parts. So I'm going to divide it right now. So I will just so from this point I will draw a line in this direction. I'll just take 15 millimeters. So this is 15, this is another 15, and this is another 15 millimeters. So I'm going to connect this point together with point MN here. So then the next thing I'm going to do is to locate a point. So alright, so I'll just shift it here like this. So we get alright, so here we have what we have this point. So as you can see that here we have what we have 2 points here. So this is 1, 2. So that means from here, so we have 2 points. We have 2. This is in 2. Why this one is what is in 1? So I can just say we have what we have. Distance from here to here to be 2, and this is 1. That is 2:1 as we have this. So the next thing that we are going to do here now is that, as we are told in the question, that the distance of point P should be it should be twice that of distance of point P from N. This distance of point P from M should be twice that of the distance of point P from N. So what we are going to do first is that I'm going to take a measurement of 40 millimeters on my ruler like this. Then I will put it at point M here and draw an arc like this. Okay, so I will also draw it down here like this. Okay, then I will now take 20 millimeters. 20 millimeters. Then I'll put at point N here, and then I'll make an arc here. Here I will make an arc. That is what that is. 40:20, which will give us 2:1. So I believe that is clear. So what I'm going to do now is that I'm going to connect this point together like this, and I will connect this point together. Okay, so connect this point together like this. So this is point P now. So here we have point P. So let's take note of that. So let's remember that distance of point P from M is 40, while that of point P from N is 20. So let's take note of that. So now the next that I'm going to do now, so based on what we are given, I will now take 50 millimeter, radius of 50 millimeters. Now that is what that is. So I'll take 50 millimeters now on my ruler. So I put it at point M here and draw an arc again, up and down here. Then I will take 25 millimeters. 25 millimeters. So which I will put on point N here. Then I'll make an arc here. Then make an arc here. That is also 2:1. So again, the next one is that I will take 60 millimeters. I take 60 millimeters on my ruler, put it at point M here, and I will draw an arc like this. So I will draw it up and down like this. Then I will take 30 millimeters. 30 millimeters. I put it at point N, and then I will draw an arc here, and I will draw an arc here. Okay. So the next is that I will take 70 millimeters. 70 millimeters. So I put it at point M here, and I will draw an arc up here and down here. Then I will take 35 millimeters, so that the ratio will be 2:1. So I believe that is clear to us. So I put at point N here, and I will draw an arc here, and I draw an arc here. So the next is that I will take 80 millimeters. 80 millimeters on my ruler like this. Okay, so I put at point M, and I will draw an arc like this, and here also. Then I will take 40 millimeters. 40 millimeters. So I put it at point N and draw an arc here. I draw an arc here. Okay, so the ratio is 2:1, 2:1. So 80:40 will still give us 2:1. So the next one is that I will take 90 millimeters on my ruler. 90 millimeters on my ruler. Then I'll put at point M here. And I will draw an arc like this. Okay, so draw an arc here. Then I will take 45 millimeters on my ruler. Okay, so I put at point N. So now I'll draw an arc here. So draw an arc here. So the last one is I will take 100 millimeters. 100 millimeters on the ruler. So I put at point M, and I will draw an arc like this. Okay, so draw an arc here. Okay, so the next is that I will take 50 millimeters on the ruler, which I will put the pinpoint at point N here, and I will draw an arc. So looking at this, so it's close already. So all I need to do now, so it's close already, so it can't cut this one. So that means this point here, I need to extend this line. So which means this point, if I extend this line here, so this point is the end on this side. So looking at what we have here, so this point here that we have in between these 2 and 1 here, so or in between M and N is the first point. This is the first point, and then so where the arcs intersect, so we are going to take note of them as I'm doing here. Okay, so this point, so will be is the end. So then we have this point. So we have this point. We have this point here. So this point here. So we have this point, and then point P is here. So all these points we are going to join them together with the use of a French curve. So which is what I'm going to do right now. So this is my French curve. So I'm joining this point together. So we need to adjust our French curve so that we can be able to get the curve, so or the locus out. So as I'm doing it here, so it's very simple. So just take your time to adjust the French curve so that you can have a perfect curve. Okay. So alright, so I can join this and this, then so you have to adjust it. Alright, so okay. Alright, so this is the locus that we are asked to produce. So another thing that we can do here, or that we may need to do here, is to okay, so for this, if I'm to draw the radius of this one, okay, so the radius of this is 40 millimeters. So I may need to write it. So for clarification, so and then so the radius of this one is 20. So this is 20, and the radius of this one from point M. So for this one, so the radius is 50. So y for this one here, so from here, so for this one, so for this, so the radius is 25. So I'm going to do that, then I will come back and show you how it will look. Alright, so this is what I was talking about. So we have drawn the radius. So this is for this one, this is 40. So from point M to this point, which we used to get point M for P first, so it's 40 millimeters. Next one is 50, 60, 70, 80, 90, and then so that of 100, the space here is not enough, so that's why I left it. So then for point P from N, so we have 20, we have 25, we have 30, 35, 40, 45, and then 50 here. So this is the locus of point P that we have to construct, and the distance of point P from M and that of point P from N are in the ratio of 2 to 1 as we are instructed in the question. Thank you, and keep on practicing. God bless you.